Hi everyone. So we've been talking now for a while about how to solve systems of equations, and we're going to learn a new trick today, a new method for solving systems of equations, and that is called substitution. So there are a few steps you're going to use, and we'll go through them when we do some examples, but the first step is to solve one of your equations for either x or y. So either variable in terms of the other variable. We'll see what that looks like. Our second step is to substitute the solution from step 1 into the other equation. So we'll substitute the solution. Step 3 is to solve the new equation. And step 4 is to solve for the second variable. So whatever variable you didn't solve for in the beginning. So second variable. All right, now let's move on to some examples. All right, so our first example is a system with y equals 2x plus 4 and 3x plus y equals 9. So let's follow our steps to solve by substitution. Well, our first step was to solve one of the equations for either x or y. But we're in luck because this first equation is already solved for y. We have y equals 2x plus 4. So we can use this and go directly to the second step, which is to substitute the solution, so the y equals 2x plus 4, into the other equation for that variable. So what I mean is that we're going to take this y equals and substitute that bit in for this y. So let's do that. So we're going to bring this one over here. We're going to get 3x plus, and then I'm going to substitute in 2x plus 4 equals 9 from the rest of this equation. Then I have only x's, so that's great. I can solve for x. So I'm going to, let's see, 3x plus 2x. I can take my parentheses away. Plus 4 equals 9. I can combine my like terms here. So those stay on the same side, so I just add them. 5x plus 4 equals 9. And then I can subtract 4 from both sides. Minus 4, and I get that 5x equals 5. Then I divide by 5, and I get that x equals 1. All right, great. We've solved for one of our variables. Now let's solve for y. So we're going to take our solution, and our third step was to solve that equation. Our fourth step is to take this solution, plug it back into our other equation, and solve for y. So we'll say y equals 2, and we know that x equals 1, so 2 times 1 plus 4. 2 times 1 is just 2, so I'll get y equals 2 plus 4, and then I get that y equals 6. So I've solved for both x and y, and if you remember, when we graphed, we would find a point where two lines intersected. This represents the coordinates of that point. So we would express this as x equals 1, y equals 6. So that's the point 1, comma 6. And that's our solution. Let's go on to another example. Okay, example number 2. We have 2x plus y equals 8, and 6x plus 3y equals 24. So we are going to have to do step 1 here, which is to solve for one of the equations for either x or y. So I think that this one would be easier to solve for x or y because I already have y with a coefficient of 1. So I can isolate it without having to divide in the end. So I'll show you what that looks like. Let's bring this over here, and we're going to solve for y in terms of x. So we will get, let's see, 2x plus y equals 8, and I want to get y by itself, so I'm going to subtract 2x from both sides. And I'll get that y equals 8 minus 2x. Okay, now I can move on. So now I can take this y equals, so this part, and substitute it in for this y over here. So I'm going to take this equation, I'll move this down here, and plugging it in, I will see that I get 6x plus 3 times this y over here, 8 minus 2x, equals 24. Now I have to do a little distribution here. So 3 times 8 and 3 times negative 2x. And I'll get 6x plus 24 minus 6x equals 24. Now, if you notice, when I'm going to combine my like terms on this side, I have 6x minus 6x. So that just cancels. That gives me 0x, which is 0. So I'm going to end up with 24 equals 24. Well, this doesn't really help me solve for x, right? Because I only have numbers. But 24 equals 24 is true, right? 24 does equal 24. So what we have here is a system of equations with infinitely many solutions. Your key to recognizing this is that you'll get an answer like this. A number equals itself. So we have infinitely many solutions. All right, let's try another example with a slightly different outcome. All right, our third example. So we have x plus y equals 4 and 2x plus 2y equals 10. So let's solve for one of our variables. And we don't always have to solve for y. I know we've been doing that for the last two problems, but we can solve for x here. So let's take this first equation and solve x in terms of y. So we'll take this over here. We get x plus y equals 4. And then we're going to solve for x. So I'm going to subtract y from both sides. And I'll get x equals 4 minus y. Now I can use this x in the other equation. So I'm going to plug this part in for this x over here. So I'm going to get, and I'll move this down, I'm going to get 2 times whatever I got for x, so 4 minus y, plus 2y equals 10 from this equation. And now I can solve for y. So I'm going to have to distribute here 2 times 4 and 2 times negative y. So I'll get 8 minus 2y plus 2y equals 10. And if I combine like terms, I see that minus 2y plus 2y is 0y, which is 0. So I get on this side 8 equals 10. Well, this again doesn't help me solve for any variables, plus 8 does not equal 10. That's not true. So when this happens, this tells us that we have no solution. So we have no solution for this problem. So remember, this happens when you end up with an answer that is not true. So you get two numbers equal to each other that are not the same. And if you remember, this looks like on a graph when we have two parallel lines and they never intersect. So there's no solution. All right, now you can try these at the bottom of your guided notes.